Welcome to a space where ideas spark curiosity, questions ignite answers, and inspiration transforms lives. This is MindAlchemy, your destination for unlocking potential in everyday life. Hello, my dear friend. Today, we will explore how to perform data classification without writing a single line of code, utilizing Weka as our trusted tool for this machine learning task. This is a dataset named socialnetworkads.csv, and this is also the same dataset as before. In this specific dataset, as you can observe, there are various user IDs. For each user ID, the dataset includes corresponding gender information, the age of the users, their estimated income, and an indication of whether they made a purchase or not, either at a specific shop or through an online offering. This purchase information is represented as a decision variable indicating whether a purchase was made or not. The first four columns, user ID, gender, age, and estimated income, are independent variables. The last column, which is the decision variable, represents the dependent variable we have discussed earlier. Right? In this dataset, the decision variable is represented as 0 or 1. Here, 0 indicates no, while 1 indicates yes. These no and yes values serve as two distinct labels within the dataset. All right. If we aim to perform classification using this dataset, what is the primary objective? The objective is that within this dataset, certain classes are already predefined. That is why this type of dataset is referred to as supervised. Classification is used for discrete values, while regression is used for continuous values, such as salaries. Here, classification deals with discrete values represented as 0 and 1 in this dataset. So, this is the Data Explorer tool. I will open the file from the desktop where the dataset is located, specifically the CSV file. In this CSV file, we have a dataset named Social Network Ads. It includes user ID, gender, age, estimated salary, and whether a purchase was made. However, the tool treats the dependent variable as continuous, calculating its mean, maximum, minimum, and standard deviation. This behavior is incorrect since the dependent variable is categorical. Now, let us perform tenfold cross-validation and examine the output. If I select a classifier, such as Random Forest, and configure the output format as plain text, let us observe whether Random Forest acts as a classifier or a regressor. Here, Random Forest functions as a regressor instead of a classifier, predicting continuous values rather than discrete class values. This is incorrect since the dependent variable is being treated as continuous in a classification dataset. To resolve this, we need to modify the last column of the dataset. We replace the 0 values with no, and the 1 values with yes. This simple modification converts the dataset into a proper classification dataset. After saving the updated dataset as Social Network Ads modified, we can re-import it. Upon loading the modified dataset, we observe that the dependent variable is now recognized as a label with 257 no and 143 yes instances. Using the same Random Forest classifier for tenfold cross-validation, we achieve an accuracy of 88.75%. Additional metrics, such as precision, recall, true positive rate, false positive rate, and ROC area are also provided. The confusion matrix reveals that 230 instances of no and 125 instances of yes are correctly classified. However, 18 instances of no and 27 instances of yes are misclassified. This results in an overall accuracy of 88.75%. Thus, we can successfully perform classification with this dataset without writing a single line of code. If you found this tutorial helpful, like this video, subscribe for more AI tips, and share it with a friend. Check the description for links to our Udemy course for automating your daily tasks with generative AI, and I'll see you in the next video.